In today's lecture, we are in MT1502L, practical based on MT1501, matrix algebra and coordinate geometry. We are in the practical number 10, polar equation of circle. Again, I am saying, if you haven't studied the theory portion of the polar equation of circle, then first of all, visit the video lectures of polar equation of circle. Then only come to this practical portion. Okay. I am quickly recalling things from the theory portion. That is, in Cartesian form, if you know the center, that is x1, y1, and you know the radius r, then the equation of circle is x minus x1 square plus y minus y1 square is equals to r square. Now, if you are thinking about in polar form, then in polar, if your center is rho alpha and radius is a, I am not keeping r because we usually take r as a variable in polar. Then the general equation of the circle having center rho alpha and radius a is r square minus 2r rho cos theta minus alpha plus rho square minus a square is equals to 0. That you know from the theory portion. Okay. Now, as you know that in Cartesian, there was some equation so called general equation of circle. Similarly, here also we are having a general equation of circle, that is r square minus 2r d cos theta plus f sin theta plus c is equals to 0 is called a general equation of circle. And when it represents a circle, as also in Cartesian we are having a condition. So here also we are having a condition. That condition is g square plus f square minus c must be greater than 0. Now, if that is satisfying, then for this circle, the corresponding center is square root of g square plus f square comma tan inverse f by g, and the corresponding radii are g square plus f square minus c. Okay. Right now, this we are keeping in mind and starting the first exercise of this practical. So let's take exercise number 1. First problem, find the polar equation of circle having center 4 pi by 6 and radius 3. So all you know is from this, all you have to put rho, alpha and a's value. So here you are having rho is equals to 4, alpha is pi by 6 and a is 3. So your equation will be r square minus 2 rho r rho cos theta minus alpha plus rho square minus a square is equals to 0. So here r square minus 2r rho is 4 cos theta minus alpha is pi by 4, sorry, pi by 6 plus rho square, that is 4 square minus a square, that is 3 square, is equals to 0. Here, that is r square 4 times 2, so it is, sorry, minus 8r cos theta minus pi by 6 plus 4 square is 16 minus 3 square, it is 9, is equal to 0. R square minus 8r cos theta minus pi by 6 plus this difference is 7 is equals to 0. So this is our required equation. Let's take one more problem. B. Find the equation. We write polar equation of circle having center 13 tan inverse 5 by 12 and radius 17. Okay, here you can simplify this equation further, okay, but we are not doing that right now. Here, tan inverse 5 by 12, so your rho is 13, alpha is tan inverse 5 by 12 and a is 17. So the equation of circle is r square minus 2r rho cos theta minus alpha plus rho square minus a square is equals to 0, as we have used previously also. That is r square minus 2r rho is 13 cos theta minus tan inverse 5 by 12 plus rho square, that is 13 square, minus a square, that is 17 square, equals to 0. So simplify this, that is r square minus 26r cos, here let me write the expansion of this, that is cos theta cos tan inverse 5 by 12 minus 26r, sorry, sin theta sin, sorry, tan inverse 5 by 12 plus 13 square minus 17 square is equals to 169 minus 169 minus 289 is equals to 0. So that is r square minus 26r. Now here we are having the case that cos theta tan inverse 5 by 12. So let the triangle having this side 5 and this side 12. So this angle is your tan inverse 5 by 12 is your tan inverse 5 by 12. So since this is 12, this is your alpha, okay, this is your tan inverse 5 by 12. Let me say theta. Sorry, theta is already taken, so take me alpha. Since this is 12, this is 5, so this is square root of 12 square, that is 144, plus 5 square, that is 25, that is square root of 169, that is 13. So this value is 13. So if you think about cos of alpha, that cos alpha is 12 by 13. So let me take here, it is cos of cos 12 by 13, sorry, cos inverse 12 by 13, and here minus 26r sine theta. Now for this, if I want to write down the sine inverse theta, then it is 5 by 12, sorry, 5 by 13. So it is sine inverse 5 by 13 plus difference of these two, that is 120, is equals to 0. So that is r square minus 26r cos theta, cos inverse cancel, so it is 12 by 13 minus 26r sine theta, sorry, here it is sine also there. Okay, so sine inverse cancel, so it is 5 by 13 plus 120 is equals to 0. So it can be seen as r square minus this is 2, 13, 26, so it is 2, so it is 24 r cos theta minus here it is 2, so 5, 10, so 10 r sin theta plus 120 is equals to 0. Okay, sorry, this is minus because this is negative term, difference is minus, here it will be minus, here it will be again minus, here it is also minus. So this is your required equation. Okay, and again you can say this is also your equation, but to simplify, this is simplification is possible, so I have done that. Okay, let's take one more problem so you can realize that how we are doing this. See, find the polar equation of circle having center 2 pi by 4 and radius square root 2. So you know that how to find out the polar equation of this, that is r square minus 2r rho cos theta minus alpha plus rho square minus a square is equals to 0. The equation is this one. So r square minus 2r rho is 2 cos theta minus pi by 4 plus rho square, that is 2 square minus a square, that is root 2 square, that is 2, is equals to 0. That is r square minus 2r, that is, let me write it is 4 because 2 times 2 is 4, so 4r cos theta into cos pi by 4. So let me write cos theta cos pi by 4 plus sin theta sin pi by 4 plus r square, that is 2 square is 4 and 4 minus 2 is 2, so it is 0. So this is r square minus 4r cos theta, cos pi by 4 is 1 by root 2, so cos theta by root 2 plus sin theta, cosine pi by 4 is 1 by root 2, so here I am writing root 2 plus 2 is equals to 0. So if you want to cancel this root 2, you can write here it is as root 2r square minus 4r cos theta plus sin theta plus 2 root 2 is equals to 0. This is a polar equation of circle having center 2 pi by 4 and radius root 2. Let's take the exercise number 2, in which you are having a reverse process, that first of all determine that the polar equation given as r square minus 2r 3 cos theta plus 5 sin theta plus 18 is equals to 0 represents a circle, and then find, if it is if it is representing circle, then find the center and radius of it. Okay, so you know that the general equation of circle is looking like r square minus 2r g cos theta plus f sin theta plus c. Let me write here r square minus 2r g cos theta plus f sin theta plus c is equals to 0. Then this thing represents circle only if g square plus f square minus c is greater than 0. So here r square is matching, so g is 3. So here your g is 3, f is 5, and c is 18. So g square minus f square minus c is 3 square, that is 9, plus f square, that is 25, minus 18 is 9 plus 25, it is 34, minus 18, so is equals to 16. So your this equation represents circle, that is of course that is greater than 0. So the radius is square root of g square plus f square minus c, that is square root of 16, that is 4, and center is square root of g square plus f square tan inverse f by g. That is square root of 9 plus 25 tan inverse f5 by 3, that is square root of 34 tan inverse 5 by 3. Okay, now take one more problem. So check that polar equation r square minus 4r cos theta minus pi by 4 minus 5 is equals to 0 represents circle, and find its center and radius, if that is representing a circle. Okay, so here one way is the usual, that is expand this, convert this equation in this form, and then compare it with the g, f, and c, and you will able to find out that this represents a circle, and then you know that how to find out values of c, f, center and radius. And one more method is direct. That is, you know that if your center is rho alpha and radius is a, then corresponding polar equation of circle is r square minus 2r rho cos theta minus alpha plus rho square minus a square is equals to 0. So here you are directly able to check that. See here, this is r square matching. Here something is 2 times r, you can match that. Here it is cos minus cos theta minus alpha is already there. So all you have to arrange a. So I am accepting that way. So here if you think about this, then your alpha is pi by 4, that is very much clear. Here 2r rho and here it is 4r, so your rho must be 2. And here your rho square minus a square is minus 5. Rho is known. So that is 2 square, that is 4. I am taking this minus 5 here, so it is 5 is equals to a square. From that, a square is 9 and I can take a is equals to 3. So rho, alpha and a are known. So directly you can collect that your center is rho alpha, that is 2 pi by 4, and your radius a is 3. If you are not satisfied with this method, then you can continue as the previous thing you have done. Okay, let me do that way also, so you can recollect that we have done. So here I am keeping the usual way, that is r square minus 4r cos theta minus alpha, that is cos theta cos pi by 4 minus 4r sin theta sin pi by 4 minus 5 is equals to 0. That is r square minus 4r cos theta into cos pi by 4, that is root 2. So 4 by root 2 cos theta minus 4 by sin pi by 4 is again root 2, 1 by root 2. So this is as sin theta minus 5 is equals to 0. So now we compare with your G, alpha and F things as we have done in the previous. So G is 2 common. So first of all, we have to take 2 are common. So now we can relate our equation to the same thing. So let me write this in that form itself. Minus 2r in bracket 2 by root 2. So let me write root 2 cos theta. Here it is again root 2 sin theta minus 5 is equals to 0. So here from this multiplier of cos theta is g, and constant multiplied with sin theta is f, and again last constant is as c. So from this, here your g is root 2, f is again root 2, and your c is minus 5. So g square plus f square minus c is 2 plus 2 minus minus plus 2, it is 5, it is 9. So your radius square root of g square plus f square minus c, that is square root of 9, it is 3, and center square root of g square plus f square comma tan inverse f by g, that is square root of g square plus f square, that is 2 plus 2, and tan inverse f by g, both are square root 2, so tan inverse 1. This is 4, so its square root is 2, and here tan inverse 1 is 2 pi by 4. So radius is 3 and center is 2 pi by 4. That is as good as we have done in this method. Okay. So in both the ways, we have checked that what is a center and what is a radius. Let's go towards some more general problem, that is C. Let polar equation that is given, polar equation is R plus 2a cos theta plus 2b sin theta is equals to c square by r. Here your a and b are greater than 0. If it represents circle, then find its center and radius. So here this r is in denominator. Let me write this here. So it will be as good as r square plus 2r in bracket a cos theta plus b sin theta minus c square is equals to 0. If you relate this with the previous situation, then your g is equals to a, f is equals to b, and the constant term is minus c square. So your g square plus f square minus c square is a square plus b square minus c square only c. So it is minus, here this I am writing as c0, so not to be get confused, okay, with the previous thing. So that is minus minus plus c0 square, and that is always greater than or equals to 0. So it will always represent a circle. Now all you have to do is find out the radius, center and radius. So radius is square root of g square plus f square minus c, that is square root of a square plus b square plus c0 square. And center is square root of g square plus f square comma tan inverse f by g, that is square root of a square plus b square comma tan inverse f by g. So it is f is a and f is b and g is a, so tan inverse b by a. Okay, so in this lecture we have solved from if center and radius is known, we have identified the equation, polar equation, and if polar equation is known, then we have identified its center and radius. The next upcoming lecture, we will see more problems related to the circles in polar equation form. The good thing is, in that we will see, as we previously have seen, that if extreme points are known, then how to find out the equation of the circle, and if one of the extreme point is known, then find out another extreme point, and some similar type of problems. Okay, so try more such similar problems at your home. Stay at home, stay safe. Thank you. If you are having any doubt, then you can ask in my Telegram channel. I am posing my Telegram channel link in a WhatsApp group. I already have done that, and you can connect me there. Thank you.